Hello friends, today we will start a very important topic about multithreading, that is difference between executor service and completable future. So what is completable future? Okay, completable future is introduced after Java 8 and completable future is for asynchronous programming. Okay, means without blocking your main thread, you can write and execute a number of tasks. When task is completed, it will notify to main thread. Let's say there are n number of tasks. Okay. First task is to get the user details. Second task is to get the course details, means whatever the products you have, whatever the courses you have. And suppose you got some Java course and you need to make the payment for that. You made the payment. Suppose all these tasks are there, right? So you can submit those tasks to the completable future. Okay, and it will then execute number of tasks, and when the task is completed it will notify to the main thread. So let's say all these three tasks are created, and in this way it will combine all the completable futures and it will return a completable future of void is all. When the all tasks are completed, then it will notify to the main thread that all our tasks are completed, and by using the join method, by using the user future dot join, product future dot join, or payment future dot join, by using the join method, you can get the result. Okay, join method retrieve result without checked exception, and it is safe because until and unless all these three tasks, all of completable feature dot all of user future, product future, payment future, all are not completed, then until that future are only get it completed, because here you can use the join safely here, because until all of the futures, other futures are not completed, then this will not going to work, or this will not getting executed, join will not get executed. So it is guaranteed that when completable future dot all of like user future, product future, payment future, all are completed, then only we will get the result here. Okay, why completable future, or what is the disadvantage of future? So before completable future, we have this executor service, right? And this executor service returns the future object. Before completable future, below are present future and executor service is present, right? So what are the disadvantages of future? We cannot complete the future manually, means if you are executing any thread, we don't have an option to forcefully complete it. If we go here, and this is the future, right? So here we submitted the task. Okay, task is submitted, but we don't have any method to this future to complete it, right? We can just check the status, it is done or not, it is done or not. It is like a loan application, like you have applied to loan for getting from loan from any bank, and you are checking, is my loan application is processed or not, is my loan application is processed or not. You are just checking it is done, and you will not get any clarity, and you will not get any notification whether your loan application is processed or not. It is like that. Okay, we cannot chain multiple futures, we cannot combine multiple futures together. See, here, just like completable future, we have changed the multiple future combined together, right? Completable future dot all of, using the all of method, we have chained user future, product future, and payment future together. But that system is not there with future object or with executor service. Perfect. Means after executing any thread and you get any response, we cannot reuse it, or simply I cannot pass the response to another thread for execution. Okay, we cannot handle exceptions also here. So exception handling is also very pure. So how to create the future objects? Actually, we can create future object using the executor service. If you go to executor service equal to executors dot new fixed thread pool, and let's say we are creating three threads. Number of threads here we need to give, let's say we are creating three threads. This is the step 1. Create a fixed thread pool with 3 threads. This control how many tasks can run in parallel. So let's say we are running 3 tasks in parallel. Okay. Create a fixed thread pool like this. We are creating a fixed thread pool, and executor service we created, and executor service dot submit method we need to call. Okay. Submit method we need to call. Executor service dot submit method we need to call for any task, right? So for getting all employees like this. So here what we did, so we created the thread pool. Let's say 3 threads are getting created. Then we in step 2 and step 3, and step 4, we created the 3 tasks. First task is to get the user details from DB, let's say. Then this task is created for getting the product details from DB for that user, and this task is for making the payment for that course you selected. Okay, now we created the fixed thread pool of 3 threads, we created the task, and now we need to submit those tasks for running, right? So future of string executor service dot submit method is there, and using the submit method we can submit the task, user task. Okay, executor service dot submit product task, executor service dot submit payment task. All these tasks we can submit for execution, and then it will immediately return future of that service. Okay, submit task to executor service, and submit immediately returns the future object. And here we have used submit, right? This submit takes a callable argument if we want to return something from it, right? See, we have written here product service, future of product service. We have written here future of payment service. We have written here future of user service. So we want to return something from that value, from that submission. Then you can use executor dot submit. And if we don't want to return anything, then we can use executor dot execute. Executor dot execute we can use if we don't want to return anything. Let's say uh, executor service dot execute method is there, right? And here also, let's say we are submitting the user task. Perfect. But this user task is returning something. Okay, callable. Hmm? It is returning callable. So that's why we cannot use that one. Okay, here. If it is runnable, then we can use that one. This runnable, let's say. And we can use this runnable inside the, let's say, this runnable, right? This runnable, let's say we can use inside the execute, but it will not return anything. If you go inside the runnable, it has a run method and return type is void. But similarly, if we go to callable, right? If you go to callable equal to null, let's say. If you go to callable, it has the call method and it returning the value. Perfect. What it is showing, the callable interface is similar to runnable in that both are designed for classes whose instances are potentially executed by another thread. A runnable, however, does not return a result and cannot throw a checked exception. Okay, but this is throwing the exception, right? If you go to runnable, then it is not throwing any exception, but callable is throwing the checked exception. Perfect. However, a runnable, however, does not return a result. Runnable does not return the result and cannot throw checked exception. The executor class contains utility method to convert from one common form to callable classes. Perfect. So in order to return the result, we can use callable. What it is written? A task that return a result and may throw an exception. Implementers define a single method with no argument called call. This is the call method. It will not take any argument and it will return the result for you. Perfect. So these are the runnable and callable things. So if we go again here, so what is the difference between executor.submit and executor.execute method? Then submit, which uses the callable, and if we want any result, then we can use submit method and it uses the callable interface. If we don't want any result, then executor.execute method you can use and it is using runnable interface. Perfect. Okay. So let's say bank loan processing is there. So let's say we want to know first executor service, right? Bank loan processing is there. You submitted the application and without callback, executor service style, if you are using, you submit the application and you keep checking, is the role approved or not? Is the role approved or not? Is the loan approved or not? You keep checking and cannot register Rogel to notify automatically. Okay. When automatically loan is approved, then proceed with the disbursement of the loan. You cannot do that. This is exactly how future.get works, because future.get keeps blocking. You will get blocked until the result is ready. So executive service, here are some one-liner codes, theoretical codes you can use or for understanding purpose. Manages and reuses a pool of threads. So let's say executor service manages and reuses pool of threads. So how to create the pool of threads? Executor service equal to executors dot new fixed thread pool, and how many threads we need to use for processing, we need to give them. Okay. Separates task submission from task execution. Task submission, this is task creation, okay, this is task creation, and task submission, this one, executor.service.submit, task submission, and task execution, how we will get? Future object.get, right? So it is separating out each and every task. Execute tasks asynchronously using worker threads. Okay, so asynchronously, all these tasks, like means how many tasks are there for us? So getting the user details, getting the product details, getting the payment details, all are the tasks. So those tasks will be executed independently if we use executor service. Control concurrence using thread pools. Here n number of thread pools are there. New fixed thread pools are there. If you press control dot here, then see how many thread pools are there. New single thread executor is there. See how many things are there. New single thread executor, new thread pool task executor, new virtual thread pool task executor, new cached thread pool. Cached thread pool is also there. Okay, all these things are there. You can use it. Prevent thread creation overhead. Like how we were creating the thread previously by extending the thread class. Okay, thread. What is this thread? This thread is nothing but a class. Okay, that implements runnable interface. So how we will use to create the thread before, by extend this in the thread class and implementing runnable interface. But no need to worry about that creating it manually. This will create it manually for you. Okay, new fixed thread pool executor. Perfect. So we can use this directly. Supports runnable and callable. We already discussed this one. Callable return result, but runnable will not return any result. Return future as a placeholder for result. If you go to executor service and when we will submit the task, then we will submit the task. As soon as we do executor.submit, then it will return the future result for you. Future of string of user future, future of string of product future, future of string of payment future. All these futures it will return. A result retrieval using future.get is blocking. See, I have used here is completed. So as soon as we submit it, and until we call the get method, this is user futures completed will return you false, and the state is also in the running state. If I run this for you, let me run it. Okay, let me debug it. So here I am creating the fixed thread pool of 3 threads. Okay, let's say 3 threads are created here. If you see, maximum pool size is 3 and core pool size is also 3. Okay, now we are creating user tasks. First we created user task, then we created product task, and then we created payment task. Perfect. So let's put here also breakpoint. Now it came here. Now executor service dot submit, you are submitting user task. But before that, just check this variable. Okay, just check this variable. Okay, now we are submitting it. Okay, now we submitted the user task. Okay, now check this. We have not called, you know, this user future dot get, right? That's why is user future completed is coming as false, and the state will also come as running only. If you check the state, then state is running. It is not completed yet, right? But see, similarly for all the other futures also. Okay, and when as soon as we call user future dot get, and then we will get the user, and then we got the user, right? If you see, we got the user Java from scratch. And now if we check this boolean value again, user future dot is done, that time it will return true. Yeah, this is true now. And then the state will state will also get completed. If you see, it is also in success state. So it is blocking, right? Until it is not completed, it is blocking one. So that's why result retrieval using future.plate is blocking, does not support task chaining, like in completable future we are chaining the task, right, one after another. Completable future dot all of, here we are using user future, here we are supplying product future, we are chaining it, right? But this is the not case with executor service. Does not support callback. Example, let's say you have submitted a loan application, right? And you keep checking whether it is loan is approved or not, approved or not. You cannot get automatic reply and approval notification. This is uh, callback is not supported. But here callback is supported. Okay, here you can check all of that, then return when it is completed, then return this thing to me. Then here you will automatically get notified. Okay, in completable future. So poor support for dependent tasks, error handling is delayed and wrapped. Developer must manage lifecycle explicitly, suitable for simple parallel task execution. Okay, simple application is there and simple parallel tasks are there. Then you can use this one. Best for legacy and blocking application. If you have some legacy code, then you can use executor service. But let's say completable future. Okay, you submit the application. You say when approval is done, call me and do this. In completable future you can do this. You submit the loan application and you will say when the approval is done, then call me and I will come for disbursement. And all these things you can handle using the notifications, and that will be automatically, you don't have to wait for it. So this is the callback behavior actually, and you can use that one. Okay, completable future. Okay, represent asynchronous computation, support non-blocking execution. You can execute your task independently. Here if you see, all of them dot then return all of them. How you got all of them object? Completable future of white, completable future of all of. Here you have given all your tasks, and you are saying, hey, E- if and only if all our tasks are completed, then only run this user feature dot join, product feature dot join, and payment feature dot join. Okay, all are completed, then only use this. You are saying there. Okay, allow chaining of multiple async stages. So here you are chaining, right? asynchronous stages, you are chaining it. User service, product service, payment service, all you are chaining with one another. Enable composition of dependent task. So all the dependent tasks are there. You can enable composition for that. Prevent Fluent functional tying API supports callback on completion. So support callback on completion, right? So whenever it is completed, then only execute this one. You are saying that future project dot join, future product future dot join, payment future dot join, all these callbacks. Whenever all these tasks are completed, then only you are submitting this one. So these are some advantages for that. So let me run this one for you. Okay, use you got user, you got product, and you got payment success, and your project ends. Okay, in completable future also, if you run this one, user, product, and payment, everything is successful. Okay, so if you have complex application and parallel processing is needed and better control is needed, then you can use completable future. Okay, thank you for watching.